Hello folks, we come to the part 3 video of the exercise 9.4. We are going to find the SN like how we were finding earlier by taking the A1 and all that. This is our A1 term, this is our A2 term, this is our A3 term and so on. By observing this, we are able to get the AK term very easily. Here our AK term will be 1 squared plus 2 squared and so on k squared. Nothing new to us. Summation n squared formula we know it is n into n plus 1 into 2n plus 1 by 6. By that idea, we will get this as k into k plus 1 into 2k plus 1 by 6. So if you want, we can expand it and keep this is 1 by 6 times k squared plus k, then 2k plus 1. So how does this expand? 1 by 6 times k 2k cube, then k squared plus 2k squared plus k. Let's see what comes. It will come to 2k cube plus 3k squared and k. So that's fine. Summation n will be ak k taking values from 1 to n. So directly 1 by 6, 2 times summation k cube k takes value from 1 to n, 3 times summation k squared k takes value 1 to n, then summation k takes values 1 to n. So let's put the values here. 1 by 6 is there, here there is a 2 and this is n into n plus 1 the whole squared by 4, and this is 3 into n plus 1 into 2n plus 1 by 6. All this is there at our tongue tapes, so we are doing it fast by 2. So what will happen? This is 2 times, this is also 2 times. So we can always take n into n plus 1 by 2 common. So what are we left here? N into n plus 1 only is left. Here it is 2n plus 1 only, 2n plus 1 only left. Then here there is only 1 left. So what will happen? N into n plus 1 by 2. This is n squared plus n plus 2n plus 2 if you want. So it's like n into n plus 1 by 2. See, this you could have taken it judiciously. N times n plus 1. 2 times n plus 1. So when you take it up common, it is n plus 1 times n plus 2, right? So your answer is n into n plus 1 squared times n plus 2 by, wait. Yeah, 2 has come out when 6 is already there. So 12. So your answer is n into n plus 1 the whole squared into n plus 2 by 12. That's how you get the sum over here. A little bit of work is there. Now, in the 8th problem, they give you the nth term. That means they give you the kth term directly. Otherwise, like we were struggling to find out the kth term, here it is directly given. K times k plus 1 into k plus 4. That's given to us. So, k squared plus k into k plus 4 as we do it always. So, let's take this. K cube plus 4k squared plus k squared plus 4k. I hope it's clear. K cube plus 4k squared plus k squared plus 4k. Yeah. So it's k cube plus 5k squared plus 4k. Right. So that gives you SN easily, isn't it? Summation AK where k will take the values from 1 to n. So it's like now because we have become experts, we are writing it directly from 1 k cube 5 times summation k taking values 1 to n k squared 4 times k taking values 1 to n k. And all these are at our tongue tips, so it's like n squared n plus 1 squared by 4, and this is 5 times n into n plus 1 into 2n plus 1 by 6, and this is 4 into n plus 1 by 2. Let's have those common things coming out. N into n plus 1 by 2, we have taken it out. Here n into n plus 1 by 2 is left. Here 5 times 2n plus 1 by 3 is left. Here 4 is left. So let's have them equalized. This should be multiplied by 3 by 2 and this by 6. So it is n into n plus 1 by 2. Here it is 3n squared and 3n. We are very careful, but we are doing it at one shot, but we are a little careful. 10 plus 2, 20n, right? 10. Right, and this is 24 directly because 6 4s are 24. We did it at one shot, but a little careful. So what is happening? N into n plus 1 by 12 because of these two. And let's see what is there here. 3n squared plus 23n plus 34. 1. Yeah. Oh, luckily this doesn't factorize further, so you can leave it like this. And your Sn values, n into n plus 1 into 3n squared plus 23n plus 34 by 12. So that's our answer, and that's how we do it. Even 9th is given in a ready-made form for us. We have ak as k squared plus 2 raised to k. So Sn will be k taking values from 1 to n, k squared plus 2 raised to k. So what will come? This is of course direct, n into n plus 1 into 2n plus 1 by 6. But this is a GP. Why? Because it can visualize this. 2 raised to 1, 2 raised to 2, 2 raised to 3 and so on, 2 raised to n. It's a GP with a as 2, r as 2, and Sn therefore will be a into r raised to n minus 1 by r minus 1. So with so much details we can do it. A for us is 2, r for us is 2, so 2 raised to n minus 1 by 2 minus 1, it's 1. So that's all. What further can we do, right? Can't do much. We'll leave it like that. So that is your sum to n terms there. Then the 10th problem, it says that it is your kth term is 2k minus 1 the whole square. So let's see how that goes. 2k minus 1 the whole square means it will be like 4k squared minus 4k plus 1. So how is your Sn? Sn is summation ak k taking values from 1 to n. As I said, we are already experts. We are taking it right away. K taking value from 1 to n, k squared 4, k taking value 1 to n, k plus 1 and k taking value 1 to n. So this is 4 n into n plus 1 into 2n plus 1 by 6, and this is n into n plus 1 by 2. Now what is the meaning of this? 1 plus 1 plus 1 plus 1 like that n times. So it is n. 1 plus 1, 2 times it's 2, 3 times it's 3, 4 times it's 4, n times it's n. So this will come to n. We could have this simplified if you want. I don't know whether it is desirable. 2 3s if you want. Then you can have it like equalized to 3. So yeah, and you can have an n out. So you are having when we have it equalized to 3, you are having 2 here, n plus 1 and 2n plus 1, and then because this has to be equalized to 3, this should be multiplied by 3, so it should be 6 times n plus 1, and this n has gone out, should be a 3 here. Yeah, this has gone, and this has gone. I hope things are okay. Let's work it out. So it is 2 times 2n squared plus n and 2n plus 1 and minus 6n minus 6 plus 3 whole by 3. So when we solve, it is 4n squared 3n, so 6n plus 2 minus 6n minus 6 plus 3, so gone, and then you have 3 plus 2 5, yeah, so it is n by 3, 4n squared minus 1, 6 minus 6 plus 3 minus 3 minus 3 plus 2 minus 1, so it's like a squared minus b squared, so a minus b into a plus b, like this is 2n the whole squared and this is 1 the whole squared, so 2n minus 1 into 2n plus 1, or you could leave it like that also. This is our sum to n terms. That's all about the exercise. We finished the exercise 9.4 from here. Now we have another voluminous exercise called miscellaneous exercise that's left, that we'll be taking it up in the next video. Thank you.